Today we're going to be talking about another set of angle pair relationships that occur when we have something called a transversal that intersects lines. So a transversal, let's write down that definition first. A transversal is a line that intersects two or more coplanar lines at one point. So what that would look like over here is if I have two lines, okay, and then these are my two lines here, and I have another line that intersects both of them at one point. Let's see, one point here and one point here. This blue line would be the transversal. The transversal, because it's intersecting the other two lines. One of the pink lines would not be the transversal because it doesn't intersect the other two. So we're going to talk about some angle relationships that are formed by a transversal intersecting two different lines. So the first one we're going to call corresponding angles. So these two angles are corresponding. And they have the same location. So if we look closely, angle 2 is in the upper right corner of these four angles here. And when we look at these four angles down here, angle 6 is in the upper right. So they're in the same location. We call them corresponding angles. Now here, we have angle 4 and angle 5. They're inside or in between our two lines, and they are on opposite sides of the transversal. Angle 5 over here is on the left side of the transversal. Angle 4 is on the right side of the transversal. So we call those alternate interior angles. So alternate interior angles. And if you think about it, it makes sense. They're on alternate sides of the transversal of each other, like one's on the left side, one's on the right side. And then, like I said, they're on the inside of the two lines that were given. Down here, you may say, well, these are on opposite sides. Angle 1 is on the left side of the transversal, and angle 8 is on the right side of the transversal, but they're on the outside of our lines. So these are alternate exterior angles, because here's the exterior, the outside of our two lines, where we drew earlier that, this would be the interior in red right here. So that means on the outside would be your exterior. So these are alternate exterior, opposite sides of the transversal, angle 1 and angle 8, and they're outside of the two lines, the two horizontally drawn lines. And then the last one, you may say, well, they are both on the same side of the transversal, and they're on the interior. And you say, okay, here's the interior, and they're on the inside. Some people in some textbooks call those same side interior angles because that's just what they are. That's what the picture looks like. But the more common term, or the more generally accepted term, is called consecutive angles. So these are consecutive angles. They're on the same side of the transversal. So these angles 3 and 5 are on the left side, and they're on the interior. So these are the four relationships that we're going to be talking about today, and these are super important in this unit and the next unit, and basically for the rest of geometry, these things are going to be coming up. So let's look at the next page. So this picture looks different than the ones up here. Our two horizontal lines up here are not parallel. Down here, lines L and M are parallel. These are two parallel lines, and T is our transversal. So what we're going to do is we're going to list all of our angles, all of our relationships, and then we can determine if some angles are congruent to each other or not. And this is only true when the two lines are parallel and cut by a transversal. Again, up here, those two lines, the two horizontal lines, are not parallel. Down here they are. So blank are corresponding angles. So let's match up our corresponding angles. So angle 1 in the upper left, and angle 5. Those are both in the upper left corners. Because again, we're going to take an angle from this set and compare it to an angle from this set. So angle 1 and 5 are in the same location. So angle 1 and angle 5. And then we have angle 2 that's in the upper right, and angle 6 is also in the upper right. So we have angle 2 and angle 6. Then we have angle 3 that's in the lower left, and angle 7 is in the lower left. So we have angle 3 and angle 7. And then finally 4 and 8. So angle 4 and angle 8. Those are both in the lower right corners. So corresponding angles are congruent or equal measure. All right, so again, this is only true if our two lines are parallel. Corresponding angles are congruent. All right, I'm going to erase this stuff here. And then what we're going to do is talk about the alternate interior angles. That's the next one, alternate interior. Okay, so if we look at angle 3, that's on the inside. Angle 6 is its alternate interior. Remember, the interior is this whole mess here. That is the interior. And angles 3 and 6 are on opposite sides of the transversal. So those two angles are congruent. Angles, 3 and 6, those are alternate interior angles. And they happen to be congruent. That's the relationship. But angles 3 and 6 are alternate interior angles. And then angles 4 and 5 are alternate interior angles. They're on opposite sides of the transversal from each other. So angle 4 and angle 5. So those are the two sets of alternate interior angles, and those are congruent. Okay, so then let's find the alternate exterior. If I have angle 1, that's an exterior angle. Angle 8 is that one's alternate exterior angle. Angle 1 and 8 are on separate sides of the transversal. Angle 1 is on the left of my blue line here. My blue line here. And angle 8 is on the right side of that blue line. So they're on alternate sides, and they're outside of the two horizontal parallel lines. So angle 1 and angle 8 are alternate exterior angles. And then we have angle 2 and 7. Those are, again, on opposite sides of the transversal from each other, and they're both outside of the parallel lines. So angle 2 and angle 7. Now, these angles are also congruent. And that should make sense, because if we know from the alternate interior angles, we know 3 and 6 are congruent because those are alternate interior angles. Well, 3 and 2 are vertical angles, so they must be congruent as well. And 6 and 3 are congruent, so those must be congruent as well. So that allows us to say angle 7 and angle 2 are also congruent. So there we're kind of using the transitive property or the substitution property of congruence along with the vertical angle theorem to prove that those are congruent. All right, now the last one, that's the consecutive interior angles. So consecutive interior angles are 3 and 5. So angle 3 and angle 5. And then angles 4 and 6. Those are on the same side of the transversal, and they're on the interior of those angles. So angles 4 and 6. Now these angles are not congruent to each other, not necessarily. So what's special about these angles is that they will add up to 180. And that should make sense because, let me just erase these colors here. Alternate interior angle says angles 3 and 6 are congruent, and angles 4 and 5 are congruent. Well, angles 3 and 4 form this straight line right here. So they have to add up to 180 degrees. Well, if angles 3 and 6 are congruent, then we can use substitution again to say angles 4 and 6 add to 180. They are supplementary because they would form a straight line. Or you could say they are a linear pair, or that they add up to 180 degrees. All means the same thing. So this page right here is really critical for you guys to have written down and to be able to refer to. If we look at the next page, I'm going to have you guys try this on your own and pause the video in a minute. So what you're going to do is you're going to be looking at each set of lines and say, okay, are the two angles here, we have CN and A. What are they in relation to each other? Are they corresponding angles? Are they alternate interior? Are they alternate exterior? Or are they consecutive interior? So you're going to go through each one of these and write the letters. So like this one, these are alternate exterior, so I'm going to write C, N, and A in that box. Okay, so you're going to go through each one of these and do that. So pause the video, and then once you have finished, unpause it so we can check it and discuss. All right, so then here are the answers for that. The N and H, those are corresponding. They're in the same location. SA and YT are consecutive interior. They're on the same side of the transversal, and inside are two horizontal lines. DO and LG over here, those are alternate interior. And then G and I, those are corresponding. and N and TO are corresponding. So we can unscramble this and say, okay, NOT and then GINH can be written as nothing if you rearrange that. And then DOLG, gold. These three letters can be rewritten as can, and then stay. So nothing gold can stay is what that would be like unscrambled. So if you weren't able to unscramble those, that's fine. I'm more concerned, were you able to recognize these angle relationships? Down here, the measure of angle 3 is 125. It's written there. Find the measure of the remaining angles. So I know that angle 1 and angle 125, those are vertical angles. So I'm going to write 125. Angles 125 right here and angle 5, those are alternate interior angles. Or you could say, well, angle 1 and 5 are corresponding and they are congruent. Then angles 5 and 7 are vertical, so that's also 125. Now you could say, well, we have a straight line right here, so if I do 180 minus 125, that equals 55 degrees. So angle 2 must be 55 degrees. And then you can go through and say angle 2 and 4 are vertical, so these are 55 degrees. And angles 4 and 6 are alternate interior, so that's 55 degrees as well. And all the other angles are 55 degrees. So you'll notice there's only two different numbers here. So then let's fill in our answers. Angle 1 is 125. Angle 2 was 55 degrees. Angle 4 was also 55 degrees. Angle 5 is 125. Angle 6 is 55. 7 was 125. And angle 8 was also 55 degrees. So these things build off of one another, so it's important that you have, again, like I said, that page up here to refer to. Right, now on the next page, we're actually going to apply these things. I want you to get in the mindset that the parallel lines do not always have to be horizontal. Like in example A here, our parallel lines are kind of going vertically. And you know that these are the parallel lines because this triangle symbol here, this symbol means parallel. Okay, so now my parallel lines are going up and down, and then my transversal is this one right here. So these two angles, 72 is above the transversal, 9x is below the transversal. They're on alternate sides, and they're on the interior of our two parallel lines. So these are alternate interior angles. So I'm going to write that down. Alt interior angles. And they are congruent. So that means 72 equals 9x. Okay, so if we divide both sides by 9, x is equal to 8. Then in example B, okay, we have this angle, 3x minus 7, and this angle x plus 5, but we don't have any special relationship with them. Like, one is on the interior, one's on the exterior of our parallel lines, and they're on opposite sides of the transversal. So they're not corresponding, they're not alternate exterior angles. So we're going to have to do a little bit of math or some other properties to get an equation set up. These two angles here that I just marked in red are vertical angles. So that means if up here is 3x minus 7, that means this is 3x minus 7 as well. Well, now what we have these two angles. Those are consecutive interior angles. And those add up to 180 degrees. So that means our equation would be x plus 5 plus 3x minus 7 equals 180. So don't get in the mindset that everything is always going to be equal to each other. Sometimes they'll add up to 180. So we combine like terms. 4x, 5 minus 7 minus 2 equals 180. So then we'll add 2 to both sides. 4x equals 182. And when we divide both sides by 4, we get x equals 45.5. We're going to extend some lines. What this will allow us to do is to kind of break up the information a little bit and kind of help us out. So we're ignoring these two lines here. So we're going to look at the red line and that pink line. What we can notice is that this 4x and this 52, those are on opposite sides of the transversal, and they're in between the two pink lines, my two parallel pink lines. So that means those are alternate interior angles. So we have alternate interior angles. And that means they are equal. So we have 4x equals 52. Divide both sides by 4, and we get x equals 13. Okay, so that's one thing that's done. Now I'm going to erase my red transversal and focus on this, my new, I'll use dark blue, this dark blue line here. So now that dark blue line is my transversal. And this box is 90 degrees. And then we have that 90-degree angle, and then we have this angle up here, this 3y plus 2 and this 4x. They have to add up to 180 because these two angles here, 4x and 3y plus 2 and this 90-degree angle down here, those are consecutive interior angles. So consecutive interior angles, and they add up to 180. So then we will have 4x plus 3y plus 2 plus 90 equals 180. So we know x is 13, so 4 times 13 plus 3y plus 92, because 2 times 90 is 92, equals 180. 4 times 3 is 52, plus 3y plus 92 equals 180. We can combine our like terms, 52 and 92, get 3y equals 144, that equals 180. Subtract 144 from both sides, we get 3y equals 36. Let me write that a little bit nicer. 36. And then when we divide everything by 3, we get y is equal to 12. And you can double check your answer. If you take x is 13 and y is 12 and plug it into this equation right here, you should get 180. If not, then you know that you calculated one of these incorrectly, and you know that you can go back and fix that. Okay, so that problem had a lot to it. You gotta know when to ignore some lines and all that. So it's beneficial to sometimes redraw the problem with the stuff that you need to know. All right, now let's look at example B here. So I have this line and this line. These two lines are parallel, and what I want to do first is look and see if I can figure out one of these angles. It's x or y. So I have that transversal. And it might be useful to rotate your paper a little bit to see what's going on. For whatever reason, when the lines are horizontal, like if the two parallel lines are horizontal, students do so much better at recognizing things. So I always tell them, hey, rotate the paper if you need to. And that might make things a little bit easier to see. So these two angles that I'm going to circle, x and 65, those are corresponding angles. They're in the same location. We are ignoring this line right now. So we're going to pretend that line doesn't exist. So then those two angles are in the same location. So x is equal to 65 degrees. Okay. Now I'm going to erase those things. So this is 65 degrees right here. We know that we have vertical angles right here. So this is 55 degrees. And then this is a straight line. So these three angles, x, 55, and y, should equal 180. So if we have 65 plus 55 plus y equals 180. 65 plus 55 is 120, plus y equals 180. Subtract 120 from both sides, and y is equal to 60 degrees. Okay. So I know that this was a lot today. We'll work on some of the ones that look like example 4 in the days to come. What I really want you to take away from this, what the main idea in this lesson is this right here, this page, and being able to apply it. So we talked about this, and then we applied it in examples 2 and 3. So those are the ones that I really want you to focus in on right now. Example 4, if you're struggling with that, that's okay, and we'll figure it out in the coming days. So make sure you like the video and subscribe.